Hello friends. In this video I am going to explain the concept of present value, which is extremely important in financial decision making. Let's understand what is the basic concept of present value. Money has time value. A dollar today is more valuable than a dollar 1 year hence. By using this analogy we can say that the value of same amount of money received or paid at different period of times is different. And why this is so? Because the money has interest element in it, and the longer we receive or make any payment, the interest opportunity is lost on that portion of money. That's why the future value is less important than the present value of money. So we can define the present value as the current value of a future amount applying an appropriate discounting rate. And how that appropriate discounting rate is derived, we will see in another chapter. So the concept of present value is just opposite and reciprocal to the future value. So to calculate the present value, we have to apply the interest discounting technique, which is just opposite to the interest compounding technique which we used for calculating the future value of money. So when we apply the discounting factor, the longer the period you receive the payment in future, the lower will be its present value of such cash flows. And similarly, the higher the rate of discounting, the lower will be the present value of a future amount. So let's understand the formula. What is the basic formula of calculating the present value is P divided by 1 plus R raised to power n, where P is the future cash flow and R is the rate of interest at which it has to be discounted, and n is the number of years to the future period from the present. We can also use the ready reckoner, which I will be explaining shortly with an example. And if we use the ready reckoner, the formula is the future cash flow, which is P times PVDF, which is the present value discounting factor of that particular year. So let's see, when there is a series of cash flow, not one particular cash flow at one point of time. So when there is a series of cash flow, either receipt or payment, each year's cash flow has to be discounted by the respective present value discounting factor, and then sum of all the discounted value or the present value of is basically the total present value of the future cash flow series. So the formula we can write symbolically in this manner. The cash flow of year 1 is to be discounted by 1 plus R raised to power n. The cash flow of year 2 has to be discounted by 1 plus R raised to power 2, and so on. So when we take the sum of all the present values cash flow, we get the total present value of the future cash flow in series. So for example, if we have year 1 $1,000 cash flow, year 2 $2,000, year 3 $3,000, year 4 $4,000, and year 5 $5,000. So we, and discount rate is 10% per annum. So what we can see, we put here in the columns all the 5 years individual cash flow, and discount rate is 10%. So each year's cash flow we discount by the respective PVDF factor, or using the formula 1 divided by 1 plus R raised to power n. So let's say, for example, year 1, what we receive at the end of year 1, $1 is equal to 0.9091 in present value terms. Similarly, the money which we received at the end of year 2 is worth 0.8264 at 10% discounting by using this formula 1 divided by 1 plus R raised to power n. We can also say this in this ready reckoner. Let me go to the ready reckoner so that the concept will become clear. So here it is the present value interest factor at 10% discounting. After year 1, this is 0.9091 in today's terms. After year 2, what we receive or make payment is 0.8264 in today's worth. So like that, here I have put on right hand side all the interest rate percentage or discounting rate, and on row side this is number of years from 1 to 100. So we can calculate the 100 years, any years discounting rate at any interest rate from this table. So let me go to the example. So like that, when we calculate the PVDF factor for each year's cash flow, we simply multiply the respective cash flow times the respective PVDF factor to calculate the present value of that year's cash flow. And when we take the sum of all the five, we get the total value of the present value of the future cash flows. Now, what happens if the discounting is to be done semi-annually or quarterly or monthly, not annually? In that case, the concept remains same, except that R, which is your rate of interest, is divided by F. F is basically the frequency of the payment of the compounding within a year. So, for example, if it is semi-annual compounding, the F is 2. If it is quarterly compounding, the F is 4, and if it is monthly compounding, F is 12, or if it is daily compounding, F becomes 365. So the rate is divided by F, but raised to power n is multiplied by F. So n is number of years. So whatever is the compounding frequency, that gets multiplied by the n to make it power of n. And P is basically the cash flow of the respective year. So let's see this example. $1,000 you receive after 24 months, and the rate of interest is semi-annually compounding. So when you do the semi-annual discounting, the 10% per annum interest rate becomes 5%. So with every 6 months interval, it gets discounted. So for first 6 months, it gets discounted by 0.9524. For next 6 months, like 10, 12 months, it gets discounted by 0.9070. So like that, in 24 months, it gets discounted 4 times using semi-annual rate of 5%. So that discount factor comes to 0.8227. So when we multiply this factor with this original amount of $1,000, we get $822.70. That is the present value of $1,000 received after 24 months. So now let's see the annuity. What is annuity? Annuity is basically when you receive or pay any fixed amount at a regular interval. That's called annuity. For example, you have the bonds interest, which is paid every 6 months at a coupon rate. So that becomes an annuity. Similarly, rent payments we are making in advance, so that's also an annuity. So annuity could be of two types. One is ordinary annuity, where the payments are received or made at the end of the each period. And annuity due is when payments are made or received at the beginning of each period. So that's called annuity due. So an example of ordinary annuity is your bonds interest, where the interest payment is made at the end of 6 months. So bond interest is basically considered as ordinary annuity, whereas rent, which you pay in advance, it could be monthly in advance, or it could be quarterly in advance, or yearly in advance, that's considered as annuity due. So when how to calculate the present value of annuity due? So in case of annuity amount, since the numerator, which is your P, is equal amount throughout the period, so what we can do, the all the PVDF factors, present value discounting factors, we can sum it together, and the sum of all the present value discounting factors, if we multiply with the P, we get the same result. So the formula becomes P times sum of PVDF of each cash flow, or alternative way, when the period is so long that to calculate the PVDF factor for every year becomes too time consuming. So we have a PVDFA table which can be used also. So let us see this with an example. If you have $1,000 received every year at the end of the year, so for next 5 years, so you receive 5,000 cumulatively, discounting rate is 10%. So the first 1,000 what you get at the end of first year is multiplied by 0.9091, because $1 is equal to 0.9091 in present value terms. Similarly, the second 1,000 what you receive at the end of second year has to be discounted by 2 compounding period. So 1 divided by 1 plus R, which is 10% raised to power 2. So that factor becomes 8.8264. So like that you get $826. So $1,000 at the end of year 2 is worth $826.456. So now like that you can calculate each year's cash flows present value, and when you take a sum of that you comes to 3790.79. Now the alternative way of calculating this is you add all the PVDF of year 5, which comes to 3.7908. Just multiply this 3.7908 with the annuity amount, so you get the same result. And third alternative way is simple ready reckoner, where I have you given this PVDFA factor at 10%, and this side is row from 1 to 100 years same way. So you have to calculate for 5 years at 10%, 3.7908. So if you simply use 3.7908 multiply by this, you get the same result. So there are various ways and means to calculate the present value of ordinary annuity. Now let's understand this pictorially. And for this, I have taken the ordinary amount same as $1,000 for 5 years, but interest rate I have reduced to 5% instead of 10% per annum. So here it is the ordinary annuity. You get $1,000 every year at the end of the every year for next 5 years. So when you apply the discounting, the first 1,000 which you get at the end of year 1 is discounted by a factor of 1.05 raised to power 1. So that is worth 952.38. The second 1,000 is worth 907 because of the discounting of 1.05 raised to power 2. So like that you do discounting for all the years cash flow with the formula 1 plus r raised to power n. So you get the total 4329.48. Now if these periods are very long, it will be very time consuming and difficult to calculate like this method. So there is a simple mathematical formula which we can use to calculate the present value of ordinary annuity, and the formula reads like this: present value of ordinary annuity equals to P, which is your annuity amount, times 1 minus 1 plus R raised to power minus n, and this whole thing is divided by R. So with this formula you can calculate very easily, and if we put the values of this $1,000 and this formula value, the value comes to 4.32948. So you get the total present value as 4329.48. Now another way to calculate is use the ready reckoner, which is PVDFA table, present value discounting factor for annuity table. So if you go to that table, let me just go there and explain. This is your present value annuity for discounting at 5%, and you have 5 years. So you get 4.3295 as the PVDFA factor. So you just multiply 4.32948 times 1,000, you get the same result, 4329.48. Now let's understand how do we calculate the present value of annuity due. Annuity due, as I said, it is when you receive or make the payment at the beginning of the period, not at the end of the period. So what happens in that case, your each cash flow discounting is reduced by one period, by 1 year, let's say. So here in this example, $1,000 is received at the time 0, then time first, then second year, beginning at the beginning of the year. So what you do when you discount, the first $1,000 is in present value $1,000 because it is already at present value terms. It is at year 0, so no discounting is required for that. The second 1,000 has to be discounted by a factor of 1.05 raised to power 1. The third 1,000 will be discounted at 1.05 raised to power 2. So like that you discount all the 5 years cash flow. So you get 4545.95. So using the mathematical formula, what you can do, you can see here, up to here the formula remains same as ordinary annuity. Only we need to multiply by a factor of 1 plus R to get the present value of annuity due. Why we multiply by 1.1 plus R? Because here each cash flow is discounted by one period less because it is paid at the beginning of the period. So each cash flow is discounted by one period less. So that's why we multiply this by 1 plus R. So using this formula, we can get Up to here we got in the ordinary annuity calculations. So we just multiply by 1.05. So we get 4545.95, which is higher than the ordinary annuity because this is discounted by one period less. So using the ready reckoner also, we can just multiply the 1 plus R to the earlier formula to get the same result. Now let's understand what is the annuity in perpetuity and how do we calculate the present value of that. So perpetuity means when a fixed cash flow stream, it could be either payment or receipt, is made with a regular period of time and forever. That means infinite life. So that is called perpetuity, annuity in perpetuity. So to calculate the present value of a perpetuity is very simple. It's basically P divided by R, where P is your annuity amount in perpetuity and R is the interest rate per annum. That is the rate at which you have to discount. So if we look at the formula definition, we can say that the present value of for annuity in perpetuity is basically is 1 divided by R, where R is your rate of interest. And how it is used, let's see an example. If you want to earn $1,000 every year in perpetuity and your rate of interest is 5%, so how much you will have to invest to earn $1,000 at 5%? It's very simple. 1,000 divided by 0.05. So you have to invest $20,000 today in present value terms to earn a regular income of $1,000 every year in perpetuity. So that's how the perpetuity is explained and the present value concept is explained. So the concept of future value, which is also crucial for the time value of money and financial decision making, I have explained in a separate video. Thank you.